Welcome to The Explainer. We're all about turning complex stuff into clear, actionable insights. And today we are digging into the AI infrastructure gold rush. But we're not just talking about chips. We're talking about a hidden profit engine that almost everyone overlooks: heat.
When most investors hear data center cooling, their eyes kind of glaze over, right? It sounds like a boring plumbing problem. But here's the thing. Hidden inside all that thermodynamics is a huge arbitrage opportunity. I'm talking about the kind of technical detail that once you get it, completely changes how you value the entire physical backbone of the AI revolution.
So what are we talking about in real numbers? How about an extra 880,000 euros per year from a single 1.2 megawatt data center node? And get this isn't from adding more GPUs or chasing new customers. Nope, this is purely from changing how it cools itself. It's pure profit, just waiting to be unlocked by upgrading from an old, clunky system to something state-of-the-art.
Look, this is way bigger than just saving a few bucks. This is about building a business model that's just fundamentally more profitable, more resilient. And understanding how this is even possible, well, that's the whole key. So let's break it down. Okay, so section 1. The secret to all this? It actually boils down to a single metric, a simple ratio that can totally rewrite the valuation of any AI infrastructure project you look at. Now, it's an engineering term, sure, but today we're going to translate it into the only language that really matters here: pure finance.
All right, so this magic metric is called PUE, or Power Usage Effectiveness. The easiest way to think about it is like a cooling tax. It's basically a multiplier on your electricity bill. So if a data center has a PUE of 1.5, that means for every single dollar you spend powering the computers, you're throwing away another 50 cents just on cooling. The dream score, the holy grail, is a perfect 1.0. That's where every single watt goes straight into computation with zero waste.
And this right here, this shows you the massive technological leap we're talking about. On the left, that's the old way, traditional air cooling. I mean, it's basically a really, really fancy system of fans. But on the right, that's liquid immersion cooling. We're talking about literally submerging the hardware in a special fluid. Now, why do that? Because that fluid is about 3,000 times more effective at pulling heat away than air. The efficiency gains are just out of this world.
And the numbers, well, they don't lie. Look at this. With that old-school air cooling, your PUE is stuck up at 1.5, maybe even higher. But switch over to immersion cooling, you can absolutely crush that number, getting it down to something like 1.05, and that is how you slash that cooling tax we talked about. That's how you drop that cool 88,000 euros straight to your bottom line, every single year.
Okay, so cutting costs is huge, right? But believe it or not, that's only half the story. The real magic, the next level play, happens when you stop thinking of heat as this annoying problem and you start treating it as a product you can sell. This is where a powerful new revenue stream opens up.
So this concept is sometimes called turning waste to treasure, and it's a perfect description. See, liquid cooling doesn't just get rid of a cost, it unlocks an entirely new revenue-generating asset. Instead of just blowing hot air away, you're now capturing that energy, that heat, efficiently in a liquid. And once you have that, you've created something valuable that you can actually go out and sell. It's like modern-day alchemy for the AI industry.
And here's the fundamental rule. The hotter the heat you capture, the more it's worth. It's that simple. The heat from air cooling, it's low grade, around 40 degrees Celsius, pretty much useless. But the heat you get from immersion cooling, we're talking high-grade stuff, 65 degrees or even hotter. And at that temperature, suddenly you have a product. You can sell it to commercial laundries, greenhouses, you name it. You've literally turned your data center's biggest headache into a premium industrial product.
All right, so you're probably thinking, okay, this is cool, but why now? What's the big rush? Well, there's a reason we're calling 2026 a major tipping point. It's because you have 4 massive, separate forces all slamming together at once, and they're turning liquid cooling from a nice-to-have into an absolute non-negotiable necessity.
And we're not talking about small trends here. This is a fundamental shift in, well, everything. The physics of the chips themselves, the actual laws on the books, the raw economics of building these things, and even the financial rewards for being green. First up, pure physics. 1,200 watts. That's what a single one of NVIDIA's next-gen B200 GPUs is going to pull. To put that in perspective, a few years ago, a top-end chip was around 300 watts. The heat density is just exploding. Trying to cool a whole rack of these new chips with air, it's like trying to cool a blast furnace with a desk fan. It is physically impossible.
The hardware itself is literally forcing the entire industry to switch to liquid. Next up, the regulators are stepping in. The EU isn't asking anymore. They're telling. This new regulation basically forces the industry's hand. It makes heat recovery a mandatory part of your business model if you're building a new data center. You can't just dump hot air into the atmosphere anymore. The law now says you must capture it and find a use for it. Game changer.
Force number 3. The economics have totally flipped. For a long time, the cost of these systems was a huge barrier. But that's over. Thanks to really mature supply chains, especially out of Taiwan's ODMs, the price for these advanced liquid cooling systems has just collapsed. It's fallen so much that the ROI is now a complete no-brainer.
And the fourth driver, a brand new way to make money, carbon credits. Here's how it works. When you sell your recycled data center heat, you're replacing heat that someone else would have made by burning fossil fuels. Because of that, you can actually generate and sell carbon credits. In the EU system, that could mean an extra 115,000 euros a year, just from a 1 megawatt node. It's another revenue stream appearing out of thin air.
Okay, so we've covered the why and the how. Now for the really practical part. How do you use this knowledge? If you're looking at investing in an AI infrastructure project, I want to give you 3 huge red flags to look for. These are the kinds of things that instantly separate the pros who get it from the amateurs who don't. Red flag number 1. If you hear a founder say something like, "Oh, a PUU of 1.3 is fine for our model," just walk away. Seriously. In the age of 1200-watt chips, a PUU of 1.3 isn't fine. It's a sign that their entire financial model is already dead and they just don't know it yet. It shows they're stuck in the past and are about to burn through your cash.
Okay, red flag number 2 is the classic line, "Don't worry, we'll implement heat recovery in phase 2. No, this is a massive tell. Heat recovery isn't some feature you can just add on later, like an app update. It's the foundational plumbing and steel of the entire building. Promising it for phase 2 is like building a skyscraper and saying you'll add the foundation later. It's a critical and very expensive mistake.
And red flag number 3, a suspiciously low price tag on the CapEx. You've got to dig into their budget. A proper, industrial-grade liquid cooling system is going to cost real money, maybe around 2.5 million euros. If you see a number way below that, don't think, "Wow, what a bargain." You should be thinking, what corners are they cutting? Because a cheap cooling system isn't a sign of efficiency, it's a sign of massive, unacceptable risk to the multi-million-dollar GPUs that are the entire point of the business.
All right, let's zoom out and put all the pieces together. The big picture. We need to see why this isn't just a technical detail about efficiency. It's about building the ultimate moat, a defensible, long-term competitive advantage in the brutal AI economy. This is where it's all heading. The data center of the future isn't some big, dumb box sitting in a field just sucking down power. No, it's a living, breathing part of a city's energy grid. And the ability to take your single biggest liability, those crippling cooling costs, and flip it into a revenue-generating, legally required energy asset, that is the ultimate competitive moat. This is the physical foundation that the entire future of AI is being built on.
So I'll leave you with this question. In this new AI economy, is your portfolio's biggest liability about to become its most valuable asset? Because the companies and networks that figure this out, the ones that master this thermal arbitrage, they won't just survive the infrastructure wars that are coming, they are going to absolutely dominate them.